I'm Tony Anselmo. I'm the instructor at Shadle Park High School for the manufacturing and production class. I'm in the area of metals, so we've got a full machine shop, and Skils'kin approached us last year and asked us if we do their design challenge for their Kaiser wire project, and presented us with 11 different challenges. And it's a great project for the kids to do. It gets them involved in the community. They're able to help others in their community. So overall, it's been a great experience for the kids. They get the application in the lab. They're able to study the theory in the classroom and really get hands-on and design in a real-world project. So it's a good thing for them, and it's a good thing for Skils'kin too. So.
What I first expected out of this challenge was to be more creative than I already was.
When we went on the field trip over to Skils'kin, we met a lot of different people. Jerry, who was in a wheelchair, managed to do basically everything on his own, but I think the goal was to open up the jobs and the project and everything else to more than just Jerry, more than just somebody in a wheelchair.
Wire spools are transported to the production area on a pallet. A new spool is turned on its side, a metal mandrel is inserted, and the 35-pound spool is picked up and mounted onto a stand like this. As you can see here, Skils'kin uses two different stands for staging of two different spools of wire.
Your challenge: transport and stage the wire.
This is basically putting the wire onto a stand. Our project's still a little bit in progress, but basically what we've done is we've taken out putting a bar through the middle completely, and we're just setting it on a stand that has things that rotate. You just pick it up. It spins.
The reason we're doing this because at Skils'kin right now, they are using a hand pipe cutter, which isn't really easy for dexterity. So we're trying to make it so that it's electronic, and all you'll need is have a foot pedal, and then we'll have a lever one too just to make it work.
For a second Kaiser wire product, 12-foot lengths of 1/4 inch aluminum tubing is cut into 4-inch sections. A handheld tubing cutter is used for this process. And here is a close-up of the measured tubing being cut.
Your challenge: cut the tubing.
I'm Caleb Mulford.
I'm Caleb Kelly.
I'm Cody Cursis.
And I'm Noah Didier. And we're doing the tube cutting, and how we came up with the idea is to have a base like this so that we could feed a part of the tubing into the base with the rotating wheels right here, so that it'll go through, and we'll have a cutting wheel. Where is that?
We'll have a mounted cutting wheel that the tube will be sitting in, and then these will rotate, spinning the tube, which will cut the tubing.
And then it'll cut to like a precise
4
inches, and then the part that we need will go into a bin, and then it'll collect, and it'll just keep feeding in as we go. We're gonna have this hooked up to it's gonna be set up so that this will spin, and it's gonna make this spin too at the same time. So while that's spinning and this is spinning, this is being cut in place.
I want to go to college for engineering and get into more of the technical aspect of being an engineer and an inventor and designer.
This would help me because a lot of my family does fabrication, so I'll probably end up doing into that. We've done fabrication here, and they do a lot of machinery work, which we had to design this first on the computer on SolidWorks just to figure out like our main plan to do, and they do a lot of that. So this will help me a lot.
This will help me in the way I want to go to college to work on motorcycles and working on things and designing things.
For me, it just helps me understand how things work and how I can make them work better and more efficiently. That's the biggest thing I've taken out of this.
Dylan Cahill.
Spencer Turner.
Zach McLean.
We did the bolt assembly challenge. When we started this project, we felt it would be a bit of a challenge, but
It's become a lot more of a challenge than we expected, but there's just some little kinks that we'd have to work out.
I think we started out with the big picture of making it simpler than having 2 wrenches and putting the wire assembly and the bolt assembly together to hopefully being able to make it so you could do it with 1 arm or 1 hand and tighten it with the wire inside the nut. So.
Next comes the stainless steel bolt assembly. This is what is required. Note that this involves the wire with the longer 1-inch welded wire end. The 1-inch twisted wire is curled around a finger into a kind of semicircle as shown. The end product of the bolt assembly should look like this. First, the 2 washers, the lock nut, and the nut are placed on the bolt. The curved wire end is inserted in between the washers and the nut is tightened with the use of 2 handheld wrenches.
Your challenge, assemble the bolt.
Our idea was have a socket welded to a piece of plate that's not going to move. 1 set of wires and then a bolt that gets a washer on it, then the wire gets wrapped around the bolt. It gets another washer and a lock washer, and then the nut. And then put a drill on a press style, and then you can run the bolt down with 1 hand. That's tight.
it would be mounted to the table as well.
Be mounted to the table, and it's going to have springs on the inside to raise it back up after it gets pulled down.
And there'll be a handle, so you can run it like that.
And it'll be mounted to this piece instead of hanging out.
Yeah.
When I first took this challenge, I think I mostly expected to challenge my creativity and thinking outside the box to make just something that's already simple even simpler. I'm Chandler Bennett.
I'm Casey Howell.
The challenge we have decided to do is measuring the wire.
On the field trip, we met Jerry, and we also met all the other people who we got to see their personality and what they can or can't do. And we somehow could take that and put it into the project so it makes it easier just for everyone to work at.
Currently, we use a device like this to measure the length of a wire. The length is determined by the product order, and this video will demonstrate the process. One end of the wire is attached to the wheel and the length is measured by counting turns of the wire around the wheel. When the proper length is achieved, the wire cutters are used to cut the wire slightly long by about a half turn. This provides enough wire to secure the coil. A common wire product is measured to 16 turns for 50 feet or 10 turns for 30 feet. To finish off the coil, both ends of the wire are twisted in opposite directions around the coil itself.
Your challenge, measure the wire.
Alright, so what we created here was a tensioner, just because when we saw Jerry spooling the wire, he had to hold it to keep the tension. This way, you don't have to. Also, this is our, it measures the wire so you can spool it up. And it can be adjusted to whatever length of wire you want it to. What we do is we just put the wire through here, and then through there, and then flip that up. We're gonna wrap the wire around here. And then it's finished. And with the design we have set up here, you never have to count any turns. It'll automatically stop on its own. And the way that these are angled, you can just easily slide the wire off and cut it and be done.
My name is Cody Milholland.
My name is Travis Johnson.
And we worked on compressing the tube challenge. The challenging part was to make it to where it was operable with one hand and easy to use, but it was a little bit of work. We figured it out.
This is a close-up of the compressed tube. Note how the welded wire is protruding from the end of the tube. Using the compression device in the photo, the end of the tube is manually compressed with approximately 1/4 inch of the wire protruding. This demonstrates the compression of the tube.
Your challenge, compress the tube.
You don't realize how difficult a simple task could be until you try and put yourself in somebody else's shoes and then try and complete a simple task.
Like, we take advantage of using two hands, and you don't realize that until you have to do something with one hand.
In our project, we used an arbor press, and we modified it to have a table to where it will accept the aluminum tubing, to where we can crush it using only one hand, where it's easy to anybody can do it. This is the normal table for an arbor press. What we did for our project for compressing the tube, we designed a table that replaces this on the arbor press. And what you do is you just take your tube and you slip it in this sleeve like that. And then you take your wire, which will hang off the bottom of the plate. And you can, once these are twisted, you slip right through. And it holds the piece so you can clamp it down with one hand. So first you'll go ahead and take the piece of aluminum tubing, slide it in the hole, and take your arbor press and set it on the end. Slide this piece through. Right there, and press. And that's that piece.
I'm Joseph Knapp.
I'm Austin Gillette. I'm Rafael Izquierdo Spencer.
Our challenge was twisting the wire. People have need for help, and if we can help them, then that'd be a great idea. Also, it provides knowledge for what works and what doesn't work for future things I'm probably going to decide to do eventually in my life, and it'll help for that. We used two different programs, SolidWorks and Rhino Cross, or
And we used SolidWorks basically to design this and print it out in the 3D printer. And that was a real big challenge. We had Raphael here do most of that.
Yeah, it wasn't a fun experience the entire time. When designing it, we came across a lot of hiccups, a lot of like glitches, and eventually we ended up with that, which
took a lot of time and effort because the program is not very fun to use.
The stripped ends of the wire are then twisted together by inserting them into a wire nut which has already been placed inside the chuck of a drill motor. The wires are twisted approximately 5 to 7 times. The drill is operated at slow speed until the finished product resembles this image.
Your challenge, twist the wire.
Originally, with this, how they twisted the wire was they had used a screwdriver with a certain tool and used both hands to twist the wires at the same time. What we were trying to do is cut down to just using one hand and twist the wire, pretty much.
We basically are using a foot pedal to power the drill, so that doesn't need to, they don't need to use their hands on that. So basically the person who's doing it right now can use his hands. He has no use of his legs, but this allows other people to be able to complete this task by using their foot. That basically powers the drill. In order for us to twist the wire, we have to open this cam that we take the two wires together and we place it inside the pliers, and then we don't have a way to hold this yet, but we're in the process of making a way to hold it. So go ahead and hold the drill. This will be mounted inside of a clamp. We take that and it twists the wire like that. Then you just open it up and it comes out and you have the twisted wire. And it twists it way more efficient than the wire nut that was used before. The wire nut needs to be replaced like almost every time you use it. So this never needs to be replaced. This is the switch that powers the drill.
What we basically built here is a gauge that says forward and reverse, and it's a speed gauge. It's just simply going to go in through here. We're going to put something underneath to keep it up into here. You just put the switch back and forth if you need it forward or reverse for whatever reason, and if you need to adjust the speed at all, you just simply remove the box and move this little gauge. We've, during this process of making this, we've ran into a lot of different building designs. We went through, I'd say like 4 or 5 different designs that some of them would have worked if we would have followed through with it, but we figured that this would be the easiest way for us to be able to get it to one hand or 1 foot, per se. And this is what we basically come up with so far.
This essentially doesn't need to be used, but there is a nice box for the only part that people who are doing this job are going to be using the foot pedal and this. And there's also a way, if they don't have use of their foot, that we can take the button out of here and mount it somewhere else inside of a box. We have a design for that too. But this is for people who don't have complete use of their arms. So this would be on the floor and they'd use their foot, and then they could use like one hand to, this will be mounted, and then they'll just use the one hand to open this and then take the wire, put it in there, close it, and then yeah, that's basically what it is.
We've designed so far.
I'm Robert Boucher, and I go to Shadle Park High School, and my project was working on the wire connector. I think the challenge is important because I think it gives it to where the people feel like they accomplished something, and they actually can show that they can actually have the job, and I think it makes them pretty proud of themselves to be able to assemble something that they couldn't before, and know that they are actually making a profit or just showing that they accomplished a task by themselves.
This is a close-up of the finished and assembled connector. This demonstrates how the connector is currently assembled. The yellow connector is opened with a handheld screwdriver. The stripped wire ends are inserted into the connector with the red inserted into the negative slot, and then the yellow inserted into the positive slot. The wires are secured with a screwdriver, and once secured, the connector is closed up again with the handheld screwdriver.
I kind of thought of like a way to make it to where they can use their just one hand and not have to worry about the wire connector moving around and also holding the wire in place too, so that you can use just the one hand for the screwdriver. I thought using a piece of angle iron and cutting the back down a little bit and just drilling some holes through it so the connector ends would go through the back, and finding some way to put little